Algebra 2 review of sections 4.8 to 410 using quadratic formula. Again, the formula is x equals negative b plus or minus square root of b squared minus 4ac over 2a. Now again, you have to have the equations in standard form. So I'll do this last one over here. And it's not standard form. Standard form looks like 0 equals x squared, 0 equals ax squared minus bx plus c. The a, b, and c are the coefficients. So I got this 5 to the other side by subtraction. So I subtract 5 from both sides. I have negative x squared plus 4x minus 5, that equals 0. So my a is negative 1, the b is 4, and the c is negative 5, a, b, c. And those get inserted into the quadratic formula. So here we go. X equals, it's negative b, but this b is a positive 4, so it's going to be negative 4 plus or minus for the square root. B squared, so it's 16 minus the 4 times a is negative 1, and c is a negative 5. I like to list all those coefficients there, and divided by 2 times the negative 1. All right, so now we have 3 negative numbers there, so it's going to be a negative 20. So it's going to be, inside the radical, it's going to be 16 minus 20. So that's going to be a negative 4. So I will have then x equals negative 4 plus or minus square root of negative 4 divided by negative 2. And this can become, again, using the, getting rid of the negative 1, square root of negative 1, square root of 4, that becomes an I, that becomes a 2. So we have then x equals negative 4 plus or minus 2i over negative 2. And you can simplify by dividing all those by 2, or actually by negative 2. I won't show that to you. On this other problem, just to make it a little easier, I'm going to change the number. I'm going to make this a 4. Just to help speed the work here of this video. So again, it's a standard form, so to graph that we have to use x negative b over 2a. So it's positive 4, so it's a negative 4. 2a, just 2, a is 1, so it's going to be negative 2. So right here is our axis of symmetry, all down there. So we put negative 2 back into the equation to get our y value. So negative 2 squared is 4. Negative 2 times 4 is negative 8. And negative 4 is going to be a negative 8 itself. So 1, 2, 3, 4, 5, 6, 7, 8. And of course, the negative 4, the c term, is going to be our y-intercept. 1, 2, 3, 4. Reflect across the axis of symmetry. And then we'll try to find the negative 1 value. Negative 1 squared is 1. Negative 1 times 4 is negative 4, so that's going to be negative 3. Negative 3, negative 4 is negative 7. 1, 2, 3, 4, 5, 6, 7. Reflect or mirror across. We'll try 1 yet. I think we can squeeze a 1 in along here. Reflect to this side. That's going to be 1 plus 4 is 5. 5 minus 4 is 1. That'll be there. It's 3 away from the axis of symmetry. 3 the other direction. And it is a greater than sign. So it's a not equal to, so it's going to be a dashed line. So you dash, dash, dash all around. Not solid. You can use test point 0, 0 for x and y. If it's a true, if 0, 0 in there, that point will be true and everything else will be true. If it's false, you can shade the outside. I just like to say this is the function which I just drew, and y is greater than it. So the answer is greater than, anything greater than will be above it, so that's going to be inside the function itself, so it's shaded inside of there. All right, solving using a table. We'll do one at the bottom of the page as well here. So on these, you've got, again, you're only graphing in one direction. There's no y, so you're just going along a number line. But you got to find the middle of the number line where the axis of symmetry is and the vertex, and then we'll go out until we find where we actually touch the graph and decide whether we're shading on the inside like we did on this one, or you shade on the outside of the graph. So first thing again, you got to use your negative b over 2a to find your axis of symmetry. So it's plus 5 over 2. So it's going to be 2 1/2. So right here is the middle of my, if it would be a parabola in 2 dimensions. So that's going to be 2 1/2. It's 2.5. Here I have 3, and then I have 4, 5, and 6, and 7, and so forth. Now, I can go to the other side equally, and these will mirror. So this is going to be, this is 3, this will be 2, this will be 1, this will be 0, -1, and -2. And now what we do now is we start, we know this is the middle, we just kind of find, we go out until we find where the parabola actually touches the x-axis, and we hope that it does. So all we have to do now is plug these values in. So I'm going to go this direction because these are numbers nicer to work with. And they can mirror across 2 to the 3, 1 to the 4, 0, and so forth. So 2 is going to be 4. Putting this value in, it's going to be 4 minus 10 is -6. Is -6 less than 0? Yeah, that's good. That's definitely a true statement. I put a 1 here. 1 squared is 1. And minus 5, so 1 minus 5 is -4. Is -4 less than 0? Well, yes, it is, so that's good. I mirror across to that side. Let's try 0. 0 is 0 less than 0. Well, no, this is not good, but just barely, and neither is this one. But 0 is the point where things change, because this is not less than 0, but it's right where things change. So this is, if I was graphing in 2 dimensions, this thing would, it's a positive, so it would come through sort of like this, okay? And we know that these are the good solutions in here. So we basically have a number line, and these points will be, it's an open circle because of the less than sign, and it's an and statement. So we could write it also as an inequality, compound inequality, where 0 is less than x is less than 5. That's that. So those solutions would be true along one dimension. All right. I'll do one more problem here for you. I will do a quadratic equation in standard form, given 3 points. And these are chosen to make it easy for you because 0 for the x makes things a little easier. You can make a system of equations using standard form. Y equals ax squared plus bx plus c. And this is xy, xy, xy. Well, we put those values into here, and the variables are a, b, and c. But thankfully, the 0 for the x, when we put it in here, will give us a quick and easy c. So we're really counting, we're finding 2, the a and b. So let me show you. You can have 3 equations using standard form, plugging these in. Here I go, kind of quickly now. So 3 equals a 0 squared plus b times 0 plus c. If I simplify this with the zeros, I just get c, well, c equals 3. And that's one of the 3 I'm going to need. I need c, I need b, and a. So now I have one. It's got to find a and b. So that gives you that one. Next one, 1 and 5. 5 is a y, so it's going to be 5 equals a 1 squared plus b times 1 plus just c. And we know what c is already. C is this 3. So if we simplify this, we have 5 equals a plus b plus the c, as we said, was 3. Subtract 3 from both sides, we have a plus b equals 2. And the last one now is the y is the x. So we have 3 equals a is x squared, so it's 2 squared plus b times 2 plus c. And it's kind of small to read, sorry. And doing all my math here. So 3 equals, this is 4a plus 2b, and c again is the 3 over here. So plus 3. Subtract the 3, it's going to become a 0. So I have 4a plus 2b equals 0. Okay, now it's a system of equation with these 2 variables, a and b. I can stack these suckers. So I'm going to bring this one over here. Doing this kind of quick here. You get 4a plus 2b equals 0. If I multiply this by negative 2, I get a negative 2b to cancel out the b's. So times the negative 2. So I have negative 2a, negative 2b equals negative 4. Those cancel. I have 2a equals negative 4, a equals negative 2. Now I got two variables found. Now to find the b, I can go back to this equation. Looks like it's the simplest one. A plus b equals 2. Well, here's a. So put the a in here, I can find b. So here's the a plus b equals 2. A is negative 2 plus b equals 2. Add 2 to both sides to get rid of that. And, oops, 2. And b equals 4. So I have a, I got b, I got c. I have to write it in standard form now. So I have y equals, here's the a, that's negative 2 x squared. Here's b plus 4x plus 3. That is the answer in standard form. Now, I can graph this and then show that these values are on the graph. I can do that quick, I suppose. So here we go. So we know that. I'll put the 3 points on 0, 3, 1, 2, 3, 1, 5, 1, 1, 2, 3, 4, 5, and 2, 3, 1, 2, 1, 2, 3. Okay, and it's a negative, so it looks like it's going to be coming down like this, but let's just see what we can do. All right, so x equals negative 4 over 2 times negative 2. That equals negative 4 over negative 4, and x equals 1. So my vertex is right here. Well, my axis of symmetry is all along 1, and hopefully that's my vertex. We'll find out in a second. I stick 1 back into the equation, and I should get the y output of whatever that is, 1, 2, 3, 4, 5. Let's see. Put a 1 here, you get negative 2. Put a 1 here, you get a 4 plus a 3. That's 7 minus 2 is 5. Yeah, that worked out. If I put a 0 in, I should get this point, and it should mirror across this. So putting 0 in here, these cancel out. It's just 3. 0, 3. You mirror across. So these points are on the graph. There you go.